Dear students, under the lecture series on graph theory, here we have a lecture 3 where we are going to learn the first fundamental theorem on graph theory, which is also known as Euler's theorem on degrees, since it was proved by the founder Euler. The statement of this theorem is the sum of the degrees of the vertices of a graph G is twice the number of edges. First, we shall understand this statement with the help of a general graph. So, let us just draw an illustration, draw a graph for illustration. After the illustration of this statement, we shall move on with the proof of this statement. Now, let us consider this graph. So, we are going to illustrate this statement with the help of this graph. We shall try to understand this theorem first. So, the theorem says that if you add the degree of all the vertices, it will be equal to twice the number of edges, because we know that P represents the number of vertices and Q represents the number of edges. Now first we shall consider the left hand side. So the left hand side of this theorem is summation over I degree of Vi, where this I represents vertex V1, V2, V3, V4, V5. So first if you consider V1, this will be equal to degree of V1 plus, because it is summation, we have to add up, and next value of I is 2. So degree of V2 plus degree of V3 plus degree of V4 and then plus degree of V5. Since we have 5 vertices, the value of I is 5, and so we have to add up degree of each vertices and we have to see what we are getting. And so this will be equal to, what is the degree of V1? So the degree of V1 is the number of edges incident with V1. So this is by the definition, which we already saw in our previous video lecture, that is lecture 1. Now, this V1 has 2 edges incident with it. Therefore, the degree of V1 is 2. So, this is 2. And then plus degree of V2. What is the degree of V2? The number of edges incident with V2, which is 2 again. So, for this also it is 2. Plus degree of V3. For V3, the number of edges, and for V2 it is 3 actually. I didn't mention this edge. So by mistake I wrote 2. So it is actually 3. So make that correction. And for V3 also it is 1, 2 and 3, because 3 edges are incident with this vertex. So 3 plus, what is the degree of V4? We have V4 here. 2 edges are incident to it. So 2, and then finally degree of V5, which is also 2. So 2. So when we add up all this, we get the value to be equal to 12, because 2 plus 3 plus 3 plus 2 plus 2 is 12. So we have got the left hand side to be equal to 12. So therefore summation over I degree of Vi is equal to 12. We have to check whether it is same as the right. On the right we have 2Q. Q is what? The number of edges. So in this illustrated graph, how many edges do we have? So the number of edges is Q, which is equal to 1, 2, 3, 4, 5 and 6. So there are 6 edges. So the value of Q is equal to 2. And what about the value of 2Q in that case? It is 12. So we observe that the degree, that is the sum of the degree of Vi, was equal to 2, and 2Q is also equal to, is equal to 12, and 2Q is also equal to 12, which that is both are same. So therefore we can say that summation over I degree of Vi is equal to 2Q, and hence we have proved the theorem with this illustration. Now we shall proceed to the theoretical proof of this statement. Hope you have understood the illustration. So this we have to prove that in general for all graphs, the sum of the degrees of the vertices of the graph is twice the number of edges. We shall see the theoretical proof of this statement now. So, as the first step of the proof, we shall consider a graph G. So first should be the assumption of a graph, that is, let capital G of V comma E, that is the vertex set is V and edge set is E, be a graph. So first we have to consider a graph G of V comma E, and let second step is we have to take P as the number of vertices and Q as the number of edges for this graph. So next is we have to consider an edge E. So if we consider an edge E from the Q edges, that is there are totally Q number of edges, we are considering one edge E. So if suppose the end vertices are U comma V, that is the edge is like this. So here you have the vertex U, here you have the vertex V, and this is the edge E. So one edge we are considering. Now if you see, the edge E is incident with both the end vertices U and V. So we say that this edge is incident with U and also incident with V. So that we will write. So that I have written here. Now what will be the contribution of the edge E to the sum of the degree of the vertices of G? How many degree will this one edge contribute? Here you will be having 1 degree and here also you will be having 1 degree. So in total, if you consider one edge of the graph G, it will contribute 2 degrees to the sum of the, it will contribute 2 to the sum of the degrees of the vertices. So that we will write. So that I have written. So the contribution of the edge E to the sum of the degrees of the vertices of G is 2. So it contributes, that is, if you consider one edge, it will contribute 2 to the sum of the degrees of the vertices. So like that, we should, if we consider each, that is every edge of G, it will be incident with 2 vertices. So because one edge when we considered, it is incident with 2 vertices. Like that, every edge of G will be incident with 2 vertices. So we will write that. So therefore I have written it. So if every edge of G is incident with 2 vertices, means what? Every edge will contribute 2 to the sum of the degree of the vertices of G. See, we considered one edge and one edge contributed 2 to the sum of the degree of the vertices of G. Like that, every edge of G will be incident with 2 vertices. Therefore, every edge will contribute 2 to the sum of the degrees of the vertices of G. So I have written that. Now if every edge contributes 2 to the sum of the degree of the vertices of G, then what will happen? The sum of the degrees of the vertices of G will be equal to twice the number of edges, obviously, because every edge contributes 2. So every edge is having degree 2. So if you add all the degrees, it will be equal to twice the number of edges. So therefore, the sum of the degrees of the vertices of G is twice the number of edges of G. So hence, this is what? Sum of the degree of the vertices of G is equal to twice the number of edges. Hence, we have proved the theorem. So I hope you would have understood the first fundamental theorem of graph theory. In our next video lecture, we will learn a corollary with respect to this theorem. So kindly follow the upcoming video lecture. Thank you.